Howdy. There is some earthquake activity in Finland, which is rather unusual. We are not too far from Outokumpu. 2 hours ago, 3.4, 14 kilometers in depth, north of Kuopio. When we go to check out the quake, I have been checking out on Google Earth. There is nothing really visible there, but here we have it. It's confirmed, 14.3 kilometers in depth. Primary data source Raspberry Shake, so it's not the University of Helsinki. Whatever that means. And here we have this kind of seismic station. I assume the quake was here, not here, but I don't know. That was very far away, so probably it took a while for the wave to get there. And when we go back up here, earlier quakes here, you will notice the strongest was a 2.4, and now we are talking about a 3.4, which is 10 times as strong. So that's a rather special quake here in Finland. And it is also rather deep, which might be of significance. When we go over to Space Weather Finland, then we can see that there has been a small spike here in the GIC, or in the power grid actually, produced by a GIC, geomagnetically induced current. But this has been quite some time before the quake. Doesn't mean that it hasn't to do anything with it. It could very well be that there has been something, that there is a relation between this peak in the power grid. Or maybe not. I think so it has. So now, let's go to something completely different. And this has been in the news some time ago. Tourism in the Instagram era. Yeah, there has been the Bronze Age, the Iron Age, and now we have the Instagram Age, or what? Yeah, and I still think, in order to have something like a Bronze Age, you need bronze. The north of Finland offers visitors one of the best chances in the world to witness the Northern Lights phenomena, but insufficient preparation may leave some aurora-chasing tourists disappointed. Yeah, there are auroras in the north, much more than here. A group of tourists exchange pleasantries and small talk around the campfire deep in the forest wilderness of Finnish Lapland. Sure enough, the auroras have appeared on the northern horizon. The group scrambles to adjust the settings on their cameras and phones, and hoping to capture what for some is a once-in-a-lifetime moment. The spectral show doesn't last very long, and the lights slowly dissipate and disappear. So now let's have a quick look at some of the pictures. Here are Northern Lights pictures. And here they even tell something. The phenomenon is caused by electrically charged particles released by the sun, hitting atoms in the Earth's atmosphere. These electrons move to a high energy state, then back to a lower energy state before releasing light. Charged particles. So we could say in layman's terms that there's stuff there. It's particles. It's matter. There's like things. It's not just radiation or something. No, there's stuff. Particles. And that's a part of my recent paper, which doesn't seem to get published because it's too thought-provoking. Yeah, I don't know what to do now. Should I rewrite it? Or I don't know. I don't know yet, so I share a part of it with you now. The Aurora is approximately the same height as where noctilucent and clouds appear. Earth's atmospheric layers, there are many, are something like a plasma pattern, each layer separated by double layers, much like we have seen in the Sapphire Project. Despite the Sapphire Project being more focused on the Sun, the author, me, thinks that some fundamental principles of the different spherical layers around the anode can also be applied to Earth's atmosphere. With the next figure, the author tried to make a comparison between the Sun's Sapphire Project atmospheric layers and Earth's atmospheric layers. Yeah, it's not really well visible because I couldn't find the picture. But the troposphere, the stratosphere, ionosphere, and stuff like that. It is in a way quite similar to what we have in the Sapphire Project. Yeah, there is a current flowing through that. The anode from the Sapphire Project is surrounded by several double layers. The picture tries to bring forward analogies of it compared to Earth's atmosphere and its layers. There are obviously striking similarities visible, but also the aspect of scalability is taken into account. Earth's magnetosphere is a byproduct of the energy confined within the plasmoid at the center of Earth. Yeah, I think there's a plasmoid at the center of Earth. In other words, when the energy input suddenly decreases, the magnetosphere will shrink in size, and therefore all the other layers of Earth's atmospheric layers would get thinner too. It might be even so that the numerical amount of these layers shrink, let's say from 5 to only 3. Such a massive change in Earth's atmosphere would quite likely lead to very bad weather. Yeah, it's a Sapphire Project. Let's give them all the credits. It's really, like, despite making or having been making this by myself, this picture, I think it's very interesting to look at. Because for those who watch the clouds, you probably have noticed that there are sometimes several layers of clouds which are moving in whatever direction. They don't have to move all in the same direction. Rarely they do. How? How is it possible? How do the clouds stay up there in the first place? Because they could be millions of tons heavy. But yet, they are still there in the heavens and do their thing. So I think they are basically blobs of energy which just excite the water molecules and it gets visible. So clouds are plasma. And let's go back to the auroras. But first I wanted to show you still yet another self-made collage, which takes also mythology into account. Here on the lower right, we have the Oxford World Classic version of the Kalevala. So at the third time he could fell the oak and shatter the world sallow, and bring down the 100-leaved. The base he thrust to the east, the top he lowered northwest, the foliage to the great south, the boughs halfway northward. I have been cutting down several trees in my life. Let me try to draw you something. That's the ground. Let's say this is just straight, and that's a tree. I have to start again because I have this little box. Let's take another color. That's a tree. The 100-leaved. And since I'm too lazy to find some brown color, that's the stump or whatever it is. So if you cut it down, let's use yellow, you cut it down. The tree will probably follow this pathway. And if you look from above, the tree, you are looking from above now. Let's make it, yeah, that's perfect. 100% A3 anomaly sketchiness. This is from the side, and this is from above. So the tree, probably, most likely, almost all of them do like that, especially if there's one tree, you know? There's not a forest, what we are talking about, there's just one tree. So it cannot get tangled up into other trees. And that's an important fact. The tree will probably, most likely, make a straight line after it's cut down. You know, this is from above. It's a straight line. It doesn't do stuff like that. But we have the surface conductivity anomaly in Finland, which is aligned more or less northwest to southeast and east to west. The base he thrust to the east. The top he lowered northwest. I still think that they are actually talking about the Berkeley current collapsing. Or in other words, the magnetosphere got either compressed so much that the polar cusps, which are here, that's Earth, that's the polar cusp, this region. There's obviously two, of course, because there's the energy going through Earth. That's why I think there might be a plasmoid at the center. The polar cusps, observations, ground-based low reconnection cells, particle signature, in situ spacecraft observation, remote particle signatures. They look like this, according to this whatever paper research. That's how the polar cusps, so to say, look like. And to me it has striking similarities with the surface conductivity anomaly. It's just in a way vice versa with the colors. So, the auroras could probably have touched the ground. And as we just have seen in the article, the Instagram H article, this is how the auroras look. There are vertical structures, obviously, because Earth's electric field is vertical. And we have also these kind of features, the bands. They are not always very well visible, sometimes better, sometimes not. Here are the vertical signatures, probably more enhanced or easier visible. Prepare to fail. There has been another picture. Yes, here. We have the bands. There's even this kind of a vortex structure here. So these are the bands of the Auroras. And here in this picture as well, the vertical structure of the Auroras is visible. So what do you think if they would touch the ground? What kind of an imprint they would leave behind? So now let's just imagine that since the auroras are electrical charged particles and stuff like that, there is electricity included into that. We might need to assume that metals could play a role in the process. So let's check out just this Metallogenic Areas in Finland paper, which is made by many people. There is lead, gold, and all kinds of things. And also one rather interesting fact, probably many people don't know, is that here is Helsinki, the capital of Finland, and here we have a belt of uranium. Never mind the uranium. But there has been another picture somewhere down here. I will put links below. You can take your time and read it. I recommend you to read it. So here's a picture. Base maps. Rare metal pegmatites, pegmatite in the legend. In the central parts of the Somero area, also called the Somero-Tammela rare metal province. Okay, we would have to read a bit more in order to figure out what exactly there is. But anyway, I created a collage once again, where we have the auroras from the article with those bands, and the map from the geological paper. And if you look at those two at once, I would say there are somehow similarities in these. So I think many of these features here in the ground in Finland, probably elsewhere as well, they are created by ground-touching auroras and not by volcanic activity. There are those bands, actually we could go back to the paper. There are those bands here in Finland with very interesting occurrences. Here's the map, the basic map. Index map of metallogenic areas in Finland. The names of the metallogenic areas are listed in table 1. There are bands of metals. Uranium here, the violet, then we have copper and cobalt and whatever you wish. And here you can see also this uranium belt around Finland. No, Helsinki. F21, Hammaslahti, that's not too far one. F20, Outokumpu. Copper and cobalt, copper and zinc. Koli, uranium. They are all in the vicinity here. On this map it's not that well visible, but we have bands of material. And for example, Outokumpu, the region here where I live, it is considered the Outokumpu allochthon. And allochthonous means that it is from somewhere else, and most often the origin is unknown. So there's a whole region here in Finland which origin is not known. You know? This should ring a bell. If you have a huge area with very interesting and much stuff, which origin is unknown, or the formation is not understood, and stuff like that, and yet you have uranium, copper, sulfur, gold, diamonds, cobalt, lithium, whatever you need. But you don't know where it's from. Really? Yeah. Maybe this is a possibility of where they are from, what created these metal occurrences. Remember the Sapphire Project with those spheres within spheres within spheres, and Earth with its spheres? I'm talking about the atmosphere, or atmospheric layers, which are spheres within spheres within spheres. And that's some 80 to 100 kilometers from the ground. Not so much after all when you think about it. Has it always been so far away, so high up in the sky? Or is there any possibility that there could be fluctuations also in the height of the auroras? Of the bands of the auroras? Yeah. Follow the rainbow and we find treasures. But this is just what I think. Hopefully someone gets excited about this. And this one person who made the comment about silica, the formation of silica. What was it? Fusing two nitrogen atoms together and you get silica? If you find my papers, you'll find my email address. Write me. Yeah. It's very interesting. But anyway, thank you for this very interesting, intriguing comment. I'm still working on it. It's very interesting. Thank you for that. But anyway, I wasn't really supposed to make a video at all, and now I made a very long one. Earthquakes, auroras, metallogenic in Finland, stuff like that. Anyway, thanks. Bye.